Hello everyone. Okay, so please someone confirm, can you hear me clearly? All good? Say yes or something in the chat. Okay. Let's start. So binary, let's see. Introduction. Knowledge of binary number system and bit manipulation is less important in coding interview, as most software engineers do not have to deal with bits, which is more commonly used when dealing with lower level system and programming language. They are still asked sometimes, so you should at least still know how to convert numbers from decimal from into binary from decimal form into binary form and vice versa in your chosen programming language. Okay, so you need like at least to know how to convert them with like Python or so. Technique, a corner case, so to be aware and check for overflow and underflow. Okay, we can see later what like they mean by this, but let's continue now. And second one is negative numbers. Okay, let's keep going. I think this will be more clear later. So technique, question involving binary representation and bitwise operation are asked sometime, and you must be Legrand, if you can mute your mic, please. No worry. Okay, and bitwise operation are asked sometime, and you must be absolutely familiar with how to convert number from decimal form into binary form, and vice versa, in your chosen programming language. Some helpful utility snippets. Test k bit is set. So you do the number, you do okay. I think this one we probably need to come back later when we like understand the bit operator and stuff, because if someone still have no idea, it's gonna be hard to see it. Okay, I did write these documents, of course, with the help of both ChatGPT. So binary representation in computing binary is, there's also this Shaza blog. Let me post it. Okay, I did post it here. So binary representation in computing binary is a base two-number system that's used to mutually exclusive state to represent information. A binary number is made up of elements called bits. Bitwise operation. Python has several bitwise operation: AND, OR, XOR, NOT, left shift, right shift. So we're gonna watch a video that will make all this clear if someone have no idea what is this. But like the important part is just now when you're using AND, you are given like two operand. So like A, for example, A and B, and this gonna result either 1 or 0. It will only give 1 if both bits are 1. So if A and B are 1, it's gonna give 1. For OR, 1 if the 2 bit is 1. So if any bit of the 2 bit is 1, it's gonna give 1. So if A is 0 and B is 1, it's gonna give 1. XOR, it's gonna give 1 if the 2 bits are different. So as long as they are different, it's gonna Mahmoud, if you can mute your mic, please. I will mute you temporarily until you fix the mic. Okay, so not in other hand is just converting. So if you have like if you have 1 1 0 0, if you do not doesn't have to operand, like you don't do like A not B, right? you just do it for one operand. So like not A, and if it was 110, it's gonna become 0011. So it converts each bit. Left shift, it add shift from left side, and right shift, it adds 0 from the right side. We're gonna see it in this video. So let's see. Let's see this video gonna explain how to convert decimal to binary, so we understand it more. Okay, let me share my screen. Pum param pum pum param pum. Pum pum. This one. Okay, I'm gonna play the video. Someone confirm you can hear the volume.
In this presentation, we will understand how to convert binary number to decimal number and vice versa. So without any further delay, let's get started. The first topic is Introduction to Numbers System. The second topic is Decimal to Binary Conversion. The third topic is Binary to Decimal Conversion. After discussing these topics, we will then see the homework problem of this presentation. So without any further delay, let's get started and let's see what is a number system first. So what is a number system? A number system is a system that represents a quantity through a set of numbers. So a number system is a system that represents a quantity. For example, I have $100 in my wallet. So currently in my wallet, I have $100. So I'm representing the money in my wallet by the number 100. So the quantity is represented through this number 100. So in this way, I can represent the money in my pocket by this number 100. The number system that is used here is decimal number system, where each digit of the number can lie in the range from 0 to 9. A number system is a system that represents a quantity through a set of numbers. I hope this is clear. Just like decimal number system, we have other number systems as well. And now I'm going to list down those number systems one by one. So let's see what are the different types of number systems we have. The first is decimal number system, which we are well familiar with. The base of decimal number system is 10, which means that each digit of the number can lie in the range from 0 to 9. So base 10 tells us the range of each digit of the number, which is 0 to 9. I hope this is clear. The second number system is binary number system, where base is 2, which means that each digit of a binary number can lie in the range from 0 to 1. Only two allowable digits, 0 and 1. The third number system is octal number system, where base is 8, which means that each digit of an octal number can lie in the range from 0 to 7. And the fourth number system is hexadecimal number system, where the base is 16, which means that each digit of an hexadecimal number can lie in the range from 0 to 9, then 10 to 15 are represented by the letters A, B, C, D, E and F. So these are all the number systems we have, and we have more number systems as well, but I'm not going to list down here. These are the basic number systems that we have. After seeing different types of number systems, we are now ready to understand how to convert decimal to binary and binary to decimal number. First, we will understand how to convert a decimal number to a binary number. So this is the next topic that we need to deal with, that is decimal to binary conversion. We are done with introduction to number system. We have understood what a number system is. Now let's see how to convert a decimal number to a binary number. Instead of going through a lot of theory, I will give you one example, and with the help of example, we will then try to understand how to convert a decimal number to a binary number. So let's consider one simple example. Here we need to convert this decimal number 25 to an equivalent binary number. Now let's try to understand why this is a decimal number. This is a decimal number because base here is 10. As I've already told you, the decimal number system has base 10 and binary number system has base 2. Base is usually written as a subscript of the number. So here this number has base 10, which means that this number is a decimal number. And now we need to convert this decimal number to its equivalent binary number, as the base given here is 2. In order to convert this decimal number to its equivalent binary number, we need to perform one procedure. For this, we need to first draw these lines. After this, we need to mention this 25, this number over here. Now we need to divide this number by 2. For this, we will mention 2 here. So 2 must be written here and 25 must be written here. This means that divisor will come here.
Wait, let me see. Okay, let me string again. I think I lost. Okay, should be back. Okay, is it back?
And
Yes, although
Let
it's
me go
not
back.
playing.
to its equivalent binary number, we need to perform one procedure. For this, we need to first draw these lines. After this, we need to mention this 25, this number over here. Now we need to divide this number by 2. For this, we will mention 2 here. So 2 must be written here and 25 must be written here. This means that divisor will come here and dividend will come here. Now we need to divide this number by 2. After dividing this number by 2, we will get the quotient and the remainder. If we divide 25 by 2, we will get 12 as the quotient and we will get 1 as a remainder. We must mention the quotient here and the remainder here. Now, after dividing this number 25, we need to divide this number 12, the quotient. Now, we need to divide this number again by 2. We will get 6 as the quotient and we will get 0 as the remainder. Now we need to divide this number 6 by 2. Again, we need to put 2 here, and as we divide this number by 2, we will get 3 as the quotient and 0 as the remainder. Then we need to divide this number 3 by 2. We will get 1 as the quotient and we will get 1 as the remainder. After this, we need to divide this number 1 by 2. We will get 0 as the quotient and we will get 1 as the remainder. Now we need to stop here. As soon as we get 0 as a quotient, we need to
Okay, who does not understand or like have question about this? Anyone? Is everyone, if like you can open mic or write in the chat? Okay, I guess everyone understand why is 1 and why is 0. Yes,
Yes,
Mitzi,
I
you
think
wanna
so.
say something?
No. Just
Okay,
no, we are good.
let's keep going.
stop immediately. Now here we got a series of numbers. These are all remainders. Now we need to read these numbers from bottom to top. Here we are getting 11001. This number 11001 is the binary equivalent of this decimal number 25. You need to remember the numbers should be read from bottom to top. So here I have drawn the arrow so that you will never forget this. So now as we read these numbers from bottom to top, we will get 11001. So this is the binary equivalent of number 25. 11001. Now let's see one more example to concrete this concept. Here 90 is the decimal number, and now we need to convert this decimal number to its equivalent binary number. We need to start with this number 90. We need to put this number over here. Then we need to put the divisor, which is 2, over here. Now we need to divide this number by 2. We will get 45 as a result, which is the quotient, and we will get 0 as the remainder. Now we need to divide 45 by 2. We will get 22 as the quotient and 1 as the remainder. Now we need to divide 22 by 2. We will get 11 as the quotient and 0 as the remainder. Now we need to divide 11 by 2. We will get 5 as the quotient and 1 as the remainder. In the same way, we will get the other numbers as well. You can check this on your own. As soon we get 0 as quotient, we need to...
Hello, just asking, are building up to bit manipulation? Yes. Yes, so we're now seeing how to convert decimal to binary or binary to decimal, then we see the bitwise operator.
Stop immediately. Now we need to read these numbers from bottom to top. Here we will get 10111010. So the binary equivalent of this number 90 is 1011010. This is what I've written here. 90 base 10 is equivalent to 1011010 base 2. I hope this is clear. Now we have completely understood how to convert a decimal number to its equivalent binary number. Now we need to head to the next topic, that is binary to decimal conversion. Let's understand how to convert a binary number to its equivalent decimal number. Let's see how to do this. In order to understand how to convert a binary number to a decimal number, we first need to understand how a decimal number is represented. Let's say that we want to represent 625. This number is a decimal number. If we want to get this decimal number, first we need to place its digits like this. 6 to 5 are placed like this. Now, in order to get this number 625 from these digits 6, 2 and 5, we need to multiply each digit by its positional weight. Now, what is the meaning of positional weight? We first need to see the position of each digit in order to know the positional weight of each digit. The position of this digit is 0. Position of 2 is 1. Position of 6 is 2. We should read from right to left and we need to start from 0. Now we know the positions of each digit. We can now easily calculate the positional weight of each digit. For a decimal number, the positional weight is always of the form 10 to the power n, where n represents the position of a specific digit. So here, positional weight of this digit 5 is 10 to the power 0, because 0 is the position of this digit 5. Similarly, positional weight of this digit 2 is 10 to the power 1, because the position of this digit is 1. As the position of 6 is 2, the positional weight of this digit is 10 to the power 2. I hope this concept is clear. Now, as we know the positional weights of each digit, we need to multiply each digit by its positional weight. So we need to multiply 5 by 10 to the power 0, then we need to multiply 2 by 10 to the power 1, and then we need to multiply 6 by 10 to the power 2. Finally, we need to add them all. After addition, we will get 625 only. So this is the decimal number representation of this number 625. Here 6 is multiplied by 10 to the power 2, which means that 6 is multiplied by 100. So we will get 600. Here we will get 20 because 2 is multiplied by 10. Here we will get 5 because 5 is multiplied by 1. 10 to the power 0 is 1 only. So we will get 600 plus 20 plus 5, which is equal to 625, or in other words 625. So in this way we can obtain the decimal number 625. I hope the concept is clear. So with this concept we can easily convert a binary number to its equivalent decimal number. This is the reason why I have shown how to represent a decimal number. Now in order to convert a binary number to its decimal number, we need to multiply each digit of that binary number by its positional weight. Let's see one example to understand this. We need to convert 1011010, this binary number, as the base here is 2, to its equivalent decimal number. In order to obtain the equivalent decimal number of this binary number, we need to multiply each digit of this number by positional weight. Positional weight of each digit of a binary number is of the form 2 to the power n, where n represents the position of a specific digit. Here the position of this digit 0 is 0. Position of this digit 1 is 1. Position of this digit 0 is 2. Position of this digit 1 is 3. So in this way we can obtain the position of each digit. Now we need to multiply each digit by its positional weight. So 0 must be multiplied by 2 to the power 0. 1 must be multiplied by 2 to the power 1. 0 must be multiplied by 2 to the power 2. 1 must be multiplied by 2 to the power 3, and so on. So first we need to write this number, then we need to multiply each digit by its positional weight, and then we need to add all of them, just like what we did here. Here we will get 1 into 2 to the power 6 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 1 into 2 to the power 1. Note that there is no need to mention 0 into 2 to the power 0, then 0 into 2 to the power 2, because 0 multiplied with anything will result in 0 only, and it will not contribute to this addition. Hence we should not mention them. Here we will get 64 plus 16 plus 8 plus 2, which is equal to 90. So this is the equivalent decimal number of this binary number 1011010. I hope the concept is completely clear. So this is how we can convert any binary number to its decimal equivalent. So I hope the concept is completely clear. This means we are done with this topic as well, that is binary to decimal conversion. As we have understood.
Okay, any question? Okay, is it clear? Okay, we can go to the next section, is the bitwise operator. So we're gonna start with this video. We're gonna learn AND, OR, XOR, and the second video we're gonna learn NOT and left shift and right shifts using Python. Please let me know to pause the video or you have question or something, so when we jump to the solving this leads code, you can have a clear idea what's happening. Okay, let's keep going.
Hello guys, and welcome to Python programming tutorials by Amul's Academy. Today in this tutorial we are discussing about the bitwise operators. So these are the operators which will work on the bits. It won't do the operation on the value, it will do the operation on the bits. Okay, so for example, if I take value 20, we can convert this value 20 to binary form. We can convert value to binary in two ways. One is we can divide the value by 2. That is, I'll divide 20 by 2. Okay, so 2 tens are 20, so remainder is 0. Next again I'll divide 2 5s are 10, so again remainder is 0. 2 2s are 4, again remainder is 1. 2 1s are 2, so remainder 0. Okay, so now I'll write this remainder like this, that is first 1 followed by 0 1 0 0 1 0 1 0 0. Okay, so if I want to represent it in the 8 bits, here we can say 5 bits, I can join 3 0 here. Now this is the value 20 in binary form. So this is the one way. Or second way is, here we can write down the values like this. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. Okay, so now we want value 20, right? We want to represent value 20 in the binary form. Here 20 is not there, so we can write 20 as 16 plus 4, right? So here we can see 16 and 4. So in this place I'll write 16 and 4 as 1, that is true. In other places I'll write 0. Okay, so this is the binary representation of value 20. In both the ways we got the same answer, right? That is 0 0 0 1 0 1 0 0. So this is the binary form of the value 20, and here we can see 0 and 1. These are called as bits, and bitwise operators works on these bits. Okay, so now we'll see what are the different bitwise operators in Python. So there are 6 bitwise operators. First one is bitwise AND, bitwise OR, bitwise XOR, bitwise complement, bitwise left shift, bitwise right shift. Okay, so here in this tutorial we'll discuss first 3. Okay, that is bitwise AND, bitwise OR, bitwise XOR. In the next tutorial we'll discuss left 3. Alright, so first is bitwise AND operator. So we can represent this bitwise AND operator like this, that is AND symbol. Okay, so this is the operator. So if I take A equal to 20 and B equal to 4, and if I want to find out A, so if you want to find out the bitwise AND of both these inputs, then we can write like this. Okay, so now we'll see what is the output for this. So here in the ideally, first I'll take A value as 20 and B value as 4, and now I'll do A, next and next B. Okay, this is the bitwise AND operator. Enter, answer is 4. Okay, so now we'll see why it is 4. So we'll do the calculation manually. Okay, so before doing the calculation, we need to know this. In the bitwise AND, if both the inputs are 1, then only output is 1. Otherwise it is 0. Here we can see when both the inputs are 0, output is 0. When one input is 0, another is 1, then also output is 0. When one input is 1 and another is 0, then also output is 0. When both the inputs are 1, then only output is 1. Okay, so you need to remember this. So now we'll do the calculation. So we took A is equal to 20 and B is equal to 4. So first we need to write down the binary form of these values. So binary form of A is 0 0 0 1 0 1 0 0. Okay, so binary form of B is 0 1 0 0. Okay, so now we'll do the calculation. So here we can see first 0 0. So we can see when both the inputs are 0, output is 0. So first output is 0. Next here we can see 0 0, so output is 0. Here we can see 1 and 1. Okay, so here we can see when both the inputs are 1, output is 1, so I'll write 1. Next 0 0, so output is 0. Here we can see one input is 1 and 0. This case 1 and 0, so output is 0, so 0. So here we can see both are 0, so 0. Here also 0 0. So we got the output like this. This is the binary representation of value 4. Here we can see this is 4 and this is 20. So we got 4. That's why in our output here we got 4. Okay, so this is about the bitwise AND operator. Next we'll discuss about the bitwise OR operator, and the bitwise OR operator is represented by this. Okay, so if you take A is 20 and B is 4, and so if you want to apply bitwise OR operation, then we need to write A bar B. Okay, so now we'll do this and we'll check the output. So here next we'll do A or B. Okay, this is the bitwise OR operator. So answer is 20. Okay, so when we apply bitwise OR operator on A and B, when the value of A is 20, B is 4, then the answer is 20. Now we'll check this manually. So in the bitwise OR, you need to remember the output is 0 only when both the inputs are 0, otherwise it is 1. Okay, here we can see when both the inputs are 0, output is 0, otherwise it is 1. Okay, so next we'll do the calculation. Okay, so first 0 0, so that is 0, both the inputs are 0, so 0 0 0, so 0, 1 1, so 1, 0 0 0. So next 1 0, so it is 1 0 0 0. Okay, so this is the binary representation of value 20, so that's why we got output as 20. Here we can see. Okay, so this is about the bitwise OR operator. So next we'll talk about the bitwise XOR operator, and the symbol is this. Okay, this is the XOR symbol. So we can write this like A XOR B. Okay, we can represent it like this. So now we'll see the output. So here A value is 20 and B value is 4. So I'll do A XOR B. Answer is 16. Okay, so now we'll see why it is 16. So in the bitwise XOR, when the one input is 1, then only output is 1. If both the inputs are same, then output is 0. Here we can see when both the inputs are 0, output is 0. When we have different inputs, output is 1. When we have same input, then output is 0. Okay, so now we'll do the calculation. So here we are doing A XOR B, and here we can see 0 0. Both the inputs are same, so that is 0. Here also we can see both the inputs are 0, so 0. Next here we can see 1 and 1, both the inputs are same, so 0. 0 0, both the inputs are same, so 0. 1 0, so here we can see both the inputs are different, so here 1. Here 0 0, both the inputs are same, 0. 0 0, both the inputs are same, 0. 0 0, both the inputs are same, so output is 0. So this is the output we got. Okay, so here we can see this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. We got the 1 at the place 2 power 4. 2 power 4 is nothing but 16. So this is the binary representation of value 16. That's why here we got the output as 16. Okay, so this is about the bitwise AND, bitwise OR and bitwise XOR operator. And if you want to convert number to binary digits, then you can use a built-in function also for that. That is called bin. So you need to write bin of, and here you can write 10. So any value if you enter, it will return the binary representation of 10. Okay, in this tutorial we discussed about the
Okay, any question, some not clear about AND or XOR or OR? If you have any question, let's address it. If not, let's go to the last part before we start the let's code. To summarize, is AND only, let me post in chat. So AND, let's give 1 when only when both bits are 1, or give 1 if any of the two bits are 1. XOR, it will give 1 if the two bits are different. Now let's see the not or complement.
Hello guys, and welcome to Python programming tutorials by Amul's Academy. So in the previous tutorial we discussed about the 3 bitwise operators, and today in this tutorial we'll discuss remaining 3 bitwise operators. So before going to that, there are 2 built-in functions which we can use to convert integer to binary and binary to integer. That is, one is int and another one is bin. So if I write bin and if I write integer value here, it will convert the integer value to binary. Okay, and next one is int, which will convert binary value to integer. For example, if I write 0b1010, okay, and enter, it is 10. So if you are not comfortable with the manual calculation, then you can use these built-in functions. Okay, so let's begin with today's tutorial. In the previous tutorial we discussed about the bitwise AND, bitwise OR and bitwise XOR, and in this tutorial we'll discuss about the bitwise complement, bitwise left shift as well as bitwise right shift. Okay, so first operator is bitwise complement. This is also called as bitwise NOT operator, and this is the unary operator. That is nothing but it contains only one operand, and this bitwise complement operator will flip the bits. Okay, that is nothing but if input contains 0, it will write 1 in the output. If input is 1, it will write 0. It will flip the bits. Okay, and this is the symbol of bitwise complement. Okay, so in the bitwise complement, if input is 0, this operator will flip this input and it will write 1. If the input is 1, then output is 0. Okay, it is a unary operator, so it contains only one operand. Okay, so next we'll take one example. So here what I'll do is I'll take a variable a and I'll store value 20 in this variable. Okay, so now this is the bitwise complement operator, then a and enter, that is minus 21. So the bitwise complement of value 20 is minus 21, and if I take 50, enter, minus 51. Okay, so there is a general formula which will tell the bitwise complement of integer value. So the formula is, if you want to find out the bitwise complement of x, that is equal to x minus 1. That is nothing but if you want to find out the bitwise complement of 20, that is equal to minus 20 minus 1, that is minus 21. If you enter 50, minus 50 minus 1, that is minus 51. So this is the general formula. So you can easily tell the bitwise complement of any integer value using this formula. So now if you want to manually calculate this and you want to check the result, okay, so then we can do that. So we took a equal to 20. Okay, so now we'll find out the bitwise complement of 20 manually. So bitwise complement is a bitwise operator, so first we need to convert this value 20 to binary form. So this is the binary form. Okay, this is 20. So if I apply the bitwise complement here, so it will flip the inputs, right? So bits, so 0 becomes 1, 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0, 0 becomes 1, and 0 becomes 1. This is the bitwise complement of 20, and this is minus 21, binary form of minus 21. That's why in the output we got minus 21. Here we can see. So if you ask how we will get to know this is the binary representation of minus 21, then you can do one thing. You can calculate the binary representation of minus 21 and you can compare it. I'll quickly tell you how to convert the minus 21 to binary form. So if I want to convert the minus 21, so first step is I need to write the binary form of 21, that is positive 21. So that is 0001 0101. Okay, this is the binary form of 21, positive 21. So next step is I need to flip this value, that is 1110 1010. Okay, so next third step is I need to add 1 here. This is the 2's complement method, 1101 1110. Okay, so here we can see both the results are equal. So this is the binary representation of minus 21, that is equal to this result. So we can say this is minus 21. So bitwise complement will flip the bits. Okay, so next we'll discuss about the bitwise shift operators, left shift and right shift. Okay, so first we'll discuss about the bit.
Someone want to say something? Yes, go ahead.
Yeah. For the complement, for the negative, we just add the negative because the binary will just be 21.
You mean here?
I'm saying
Yes.
we are saying the complement of 20 is negative 21. But if we convert it manually, it will be just 21. So we just add the negative arbitrarily, or how does it come about?
So the negative is the last bit right here to the far left. So when the last bit of the far left bit is 1, we know it is a negative number. If it is 0, we know it is a positive.
Okay.
Did I answer your question or I misunderstand?
Yeah. It's okay. I understand now. Yeah, you answered.
Okay.
And right shift. Okay. Okay, so first we'll discuss about the bitwise left shift. So this is the symbol for bitwise left shift. Okay, in the bitwise left shift, it will shift the bits towards left. Okay, so the general form is like this: x n. Here x is the value which we want to shift, and n is the number of shift, how many bits you want to shift. Okay, so we'll take one example. So here I'll take a is equal to 20 and I'll use left shift. Okay, I want to shift 2 bits, so I'll write 2 and enter. Answer is 80. Okay, so if you left shift a by 2 bits, then answer is 80. So if you want to check that manually, then a is equal to 20, so I need to write 20 0 0 0 1 0 1 0 0. Okay, so this is the binary representation of 20. Now we want to do bitwise left shift, and we want to shift 2 bits, right? So here each bit will shift. Okay, so this will discarded, this will discarded, and this will be shifted here, 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 this will be shifted here. So here we can see 6 bits and 2 bits are discarded. Next we want 2 bits, right? So for that I'll add 2 zeros. So in the bitwise left shift, whether it is a negative value or a positive value, you will add zeros. Here we can see we added 2 zeros because we shifted this value by 2 bits. 2 bits are discarded and we added 2 zeros. So now if we check this result, this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So we got the 2 power 4 plus 2 power 6. Okay, so 2 power 4 is nothing but 16, 2 power 6 is nothing but 64, right? So if we add this, it is 80. That's what we got in our output, right? Okay, so this is about the bitwise left shift. So next we'll talk about the bitwise right shift. Here bits will be shifted towards the right side. Okay, and the symbol is this. Okay, so this is the bitwise right shift, and the general syntax is this. Here x is the value, n is the number of bits you want to shift. Okay, so we'll take the example now. I'll take a only and I'll shift. Answer is 5. If you use bitwise right shift on value 20, answer is 5. So now if you want to check the result, then we took value 20, so that is 0 0 0 1 0 1 0 0. Okay, so now we want to shift to right. This will shift to this place, this will be here, next this will be here, 1 will become here, next this 0 here, 1 here, next these 2 bits are discarded. Okay, so now, okay, here we can see at the left side 2 bits are empty, so we need to fill that. So for that I'll fill. So here we took
Wait, I didn't see your question. Yes, Legrand.
Hello.
Yes, welcome.
I would like to ask another question about
Yes, please.
the sign bit, because I didn't understand clearly.
Mm-hmm.
If it's the bit number 7, I think. So every time we just consider it like the sign bit, or we can also use it to convert the result. Like, can we raise 2 to the power 7, or this first bit is always supposed to be reserved for the sign?
I think it depends which max bit you're. For example, if you're working in 32 bit, so the last bit 32 gonna be for the sign.
Okay.
Like representing the sign. Wait, let's ask ChatGPT about this. Maybe we'll make it more clear. How do I know if, or like, when I should consider the last bit as sign bit when dealing with binary and bitwise operator? In binary representation, the leftmost bit, most significant bit, is often used as the sign bit is sign integer representation. The remaining bit represent the magnitude of the number. This is common convention in two complement representation, which is widely used. Okay. Unsigned integer. In an unsigned integer, all bits are used to represent the magnitude of the number. So when you're dealing with unsigned integer, that means even that last bit is also a value, not representing the sign of the number. There is no signed bit, and the binary representation is treated as positive integer. Signed integer to complement is signed integer using two complement representation. The leftmost bit is sign bit. If the sign bit is 0, the number is positive, and the remaining bit represent the magnitude. If the sign bit is 1, the number is negative, and the remaining bit represent the magnitude in two complement. For example, in a 8-bit two complement representation, 0 represents positive number, 1 represents negative number. I guess it's clear, right? I'm not gonna lie, I'm still also confused this part of the complement. Sometimes I don't get it.
Okay.
But so far I know it's like, it depends if you're like working with 8-bit or like a 32-bit. If it is signed integer, so you know the last bit is representing sign. Okay, any question? You can look it more. Zoom your screen. Okay, I'm sorry. Let me share the link just in case. Copy link.
Sorry, I have a question.
Yes, please.
It sounds funny, or I don't know if it's.
I wanna laugh.
Like what I want to say is gonna sound funny. Really, like, okay, now the ladies used right shift to 2 and got 5. Can we say that indirectly she said 20 divided by 4? Is that it? So if we can test it with maybe a different number, maybe let's say 100, we might get 25. I'm just asking. I don't know. It may be wrong. Just a guess.
No, you're right.
Really?
So, for example, so when we deal, let me read this. So the right shift, this operation takes two numbers. Right shift the bit of the first operand. The second operand decides the number of places to shift. If it effectively divides the number by 2 for every position, it shifted rounding down. So yeah, it's like it divides by 2. And the left shift is multiply the number by 2. So you're correct.
Oh, okay. Thanks.
Took the value 20, which is a positive value. So
Any question, you beautiful souls? Okay, let's keep going. Don't be shy to ask.
here I'll fill 2 zeros here. Okay, here 2 values are discarded. That's why we need to add 2 values at the left side. In the bitwise right shift, if the value is positive, then we'll add zeros at the left side. If we take negative value, then we need to add 1 at the left side. Okay, that is here, left side. Okay, so now if we calculate this, here we can see this is the binary representation of value 5. That's why in the output we got value 5. Here we can see. So this is about the bitwise right shift, where we'll shift bits towards the right side. So bitwise left shift, where we shift the bit towards the left. Okay, and this is the symbol, and we can mention how many bits we want to shift. Okay, this is the example for value 20. This is the binary representation of value 20, and here we can see the left shift. This is the left shift. So because of left shift, these 2 bits are discarded. Here we can see we move the bits towards the left. Next we'll get 2 empty places where we filled 0, because in the bitwise left shift, whether the value is positive or negative, we'll fill the 0 at the right side. Okay, this is the right side and this is the left side, and we'll fill 0 at the right side, whether it is a positive value or negative value. Okay, so next is bitwise right shift, where we'll shift bits towards the right side, and here we can see we took the value 20 and this is the symbol, and we can see we are shifting the bits at the right side. Because of that we lost these 2 bits. Okay, these 2 bits, and here we can see 2 empty places at the left side. So in the bitwise right shift, if the value is positive, then we'll add zeros at the left side. Okay, if the value is negative, then we need to add 1 in this place. So we need to add 1 if the value is negative. For example, if I take minus 20, then I need to add negative at the left side in the bitwise right shift. But in the bitwise left shift, whether it is a positive or negative value, we'll add zeros at the right side. Okay, so that's it for now. Thank you for watching. Don't forget to subscribe to my channel.
Okay, I make sure to subscribe. Thank you. I'm already subscribed. Make sure you guys subscribe. So now we saw everything. Please, if you have some.
This lady is she's very intelligent.
That is true. Now let's see if we can understand this, right? We come back to it, and please, if you have any question, let me know. So what we said is this gonna set the key bits to 1. You know what, let's maybe take them to Excalibur and see them. How do you work? So number, and so what does mean? This k bit is set to 1. So for example, k in this case gonna be number. Let's just do 3 as decimal. How much is that binary? 100. I think. Okay, so 0 1 0 1 1 1 0 1 2 3. So 11. So 11 11 is 3, so num, which is 3 and 0 1 1 and 1 shifts it to the left. Okay, let's say we want to set the bit 3, right? 3. So this is bit 0 0 1 2, so bit 2, bit 2. What this mean here? Not equal 0. This, oh, so this is test if it is equal 0. So if this is gonna be true if this is 1 and this is 1. Okay, so there is this operation which tests this side and this side, and there's this operation which check if it is 0 or 1 or different than 0. So this to be true, the number should be 1, and it will give 1 only if this part is 1 and this part is 1. So how we can do that? Simple formula. So if this gonna set the bit to 1, it's gonna be 1 1 1. How much is that in binary? Let's convert it. Let's convert it. Binary to decimal.
It's 7.
7. Okay.
That's
So
7, yeah.
7. So it's gonna do 0 1 1 1, and first it's gonna do this right here. K shifts by, oh, it's gonna shift. First it's gonna do this operation where it's gonna be 1. Let's do this operation. Oh, what it's gonna be? So 1 is 0. So this is 1 binary, right? Let's say where this is 1. We're gonna add 2 0 from the left side, right? So we're gonna add 2 0 here from the left side. Now we have a new value 100, which is this 6?
4.
4.
I think
Okay.
it's 4 4.
4. Now we have here 4 right here, which is 100, and operation with 0 1 1. It's gonna give what? It's gonna give 0, right? Test key bit is set. So if this gonna be
Sorry,
false,
how did you get 011? Sorry, I'm lost. How did you get
0 1
011?
1. Okay, so
So
we
I
are,
think
Okay, from 3. Okay, from the 3, right? Okay, 3.
Yes.
Okay, nice.
yes.
So
So
you're supposed to use AND operator with the
Yes.
I think
4, right?
So what this technique is? Wait, can you repeat what you said the last, Pascal?
I say you have to use the AND to and this 011 and whatever you got from the the left
Yeah,
shift.
and this with this.
Yeah,
Um,
and this, yes.
so this technique, for example, we have number 3. We wanna test the bit 0. What's the value? And bit 0 gonna have either value 1 or 0, right? Bit 2. Bit 2 of 3. Now let's see. 3 is 0 1 1 and 0 all the left side, right? All 0. Or let's say we're working in 8 bits, so it's gonna be 8 0 here, 4 0 4 0, right? 4 4 4. So this is number 3 in decimal. Now maybe the question was test the bit number 2, what value it is. Now this calculation right here, it's gonna give us the value of that bit, this right here. When I'm gonna put num, which is 3 and 1, I'm gonna shift 1 by the 2 I'm looking for, 2, and I'm gonna do check if like not equal to 0. So this operation is gonna be true if the bit was 1, it's gonna be 0 if the bit 2 was 0.
But that, I think that bit is the third
Yeah,
bit.
I guess.
Can you repeat that? That is what?
Is that not the third bit?
Uh,
Where you have your 2 there.
This one, K. So this is
No,
K.
the other one.
This is the value
Yeah,
3.
but that will be the third bit. Based on what what your representation is showing.
The pad
That's
bit, the
0 will
pad
be
bit
the
is
third
this one. But I'm confused a bit from your question.
No, I'm talking about this your representation where you have
Oh, this one.
0, 0,
This
0,
one
0, 1. Yeah, that bit is the third bit. It's not the second
is
bit.
the what? Is the what bit?
The third bit, the third one. So that would be like 3, and it's not set.
Okay, I can
So you
someone
start
explain?
counting the bits from 0, 1, 0, 1, 2. That's why you start counting the bits. Because the first bit is 2 raised to the power 0. So that's how you start counting it. So 0, 1, 2. So that's the third. The third bit is at 2.
What is third bit?
Not,
I'm not sure what is that.
it's counting it from 1. I mean, the power, that's the what you put there. You say it's supposed to be 3, not 2.
Okay, so 1 is bit 0. 1 is bit 1. 0 is bit 2. 0 is bit 3. So we start from 0.
But that's what I mean is like what I'm getting from what they are saying is like you want to test that particular bit. You know, you have 8 bits here.
Yes. So this bit.
If you count it, it will be 1 to 8. So each of them is a bit. So you have 8 bits.
Okay.
But instead, they are using the power of that representation.
No, I'm
Instead
not
of the
using.
actual.
Wait. Maybe I'm wrong, but is this the bit 0? Like if they say test the K0, which one gonna be?
So that K will be the number of the bit. So for example, now you want to check the last bit. That's the 8th bit.
The last bit is gonna be bit 7. So 0, 1, 2, 3, 4, 5, 6, 7.
But okay.
This is what I remember. I could be wrong. We can ask GPT or someone can correct me. If
I think you're correct.
I'm dealing
Well, you can go ahead and ask
with
him.
binary,
You're correct.
and for example, 3 is 0, 1, 1. Or do I say the bit 0, 1, 2, 2 is 0 or bit 3? Do we start from 0 or 1? So in computer science and programming, bit indexing typically starts from 0. So if you have binary representation like 0, 1, 1, 1, the bits are indexed as follow. Bit 0 is 0, bit 1 is 1, 1. Here in this side he starts from the left side. I think he's sick or something. But yeah, so this is bit 0. So if they say test the k of the bit 2, we can use this technique. How it work, we can like try explain again quickly. Is first let's solve this part of this equation. This what's gonna do is gonna put 1 binary if 1 is 1, right? 0 0 0 0 0 0. We're gonna shift it from the left by 2 0. So the left shift is gonna add 0. If we add 0 to this, basically it's like you're gonna take them from the end and put them here. It's gonna become 100. Now here this is 100 and this is 11. End of this is gonna be 0 1 1 and 1 0 0. Now this gonna be 1 0 0 1 0 0 0 and 1 0. So this is 0, which means this k2 is set to 0. What if it was set to 1? Then here it's gonna be 1, right? And then 0 0 1 1 is 1. Then it doesn't equal to 0, so it is true. 100 is not equal to 0. So this is one of the technique. I will let you maybe guys go over them so we can jump to Let's Code yourself. So basically, if you like, you understand the operand or like the operation bitwise, this is gonna be easy to understand. So this is gonna set the k. If we use this, we're gonna set the k to 1. Basically, we did understand it here. This is the set key. We set the bit 2 to 1, and this gonna turn off k bit. So this is the same one as we did use here. It's just we're gonna add it with end and not. This is sign of not. It's gonna turn off that bit. So if it was 1, it's gonna become 0. If it was 0, it's gonna become 0. This gonna toggle, so it's gonna inverse that bit. So if this was 1, gonna become 0. If it was 0, it's gonna become 1. This is multiplied by 2, divide by 2, the left shift. Check if number is power of 2. Okay, I have no idea how does that work, but we can check it later. Swap into variable. Okay, now let's jump to the sum of two integer. Let's code how we can solve this problem. How we can solve this problem. I have a lot of open window. Okay. So let's read it. Sum of two integer. Given two integer a and b, return the sum of the two integer without using the operator plus and minus. So we have a here is 1, we have b 2, it's gonna give us 3. Now we need to do this with what we learn is the operation that we saw, and or let me take them from the picture. 1 second. Where is it? Okay, so we have only this, and we need to do this plus operation with this operation we have here. Let's see how we can do this. So given two integer a and b, return the sum of two integer without using operation plus or minus. Okay, so any Ibong, your mic was on. Someone was singing. Happy you have a happy day. Okay, so now how we can do this? We know all of this operation how to work. How we can create 1 plus 2, which means like 1 plus 2 to give us 3. Now we need to use operation or like binary. What is 1? Let's see. 1 is 0, 0. Let's just use 4. And 2 is 0, 1, 0, 0. So this should give us 3. What is 3 in binary? Is 0, 0, 1. So how we can do this? Using this and or and XOR. Who have any idea?
Is that 3 or 4?
I believe. Oh yes, it's 4. It's 4. Sorry. 11.
I was wondering.
Yes, yes.
Zero, one,
Supposed to be 0, 1, 1.
Zero,
Yes,
one, one.
please correct me.
Yes.
Yes,
One, yes,
so
yes, exactly.
it should be 3.
I think all will work here.
So that's an all now. All.
Or
That's an all operator. Yeah, all.
okay,
But will
so
it work for everything? That's what we need to check.
so we can do or. It should work, right?
Yes.
Can you
yes.
try, sorry, Musif, can you try something like 3 and 5? Let's see if it's going to give us 8.
3 and 5.
Let's see if it's going to give us 8. Yes, 3
Okay,
and 5.
or here is working fine. 3 plus 5. 3 is 0, 0, 11. 5, I don't know. Any help?
101.
100.
5 is 0, yes, 101, yes, exactly.
Okay.
Exactly.
How you guys remember this stuff very quick? Holy. Okay, so
The Linux command, how do you call it? The security thing. How do you set
oh,
the permission?
oh, I see.
Like
The
7,
shmod.
5. Yeah, the CH mod.
Nice, amazing. Okay, so one, so 1 1. Now we are using pure or 1 1. Oh, there's problem here, right? Is it?
1, 0, 0, 0.
Wait. Let's do. So this should be 8. 8. What is 8 in
8 is 1000.
1000? Okay. So if we did use or, it's gonna give us 1 1. It's gonna give us 1 1 0. It's gonna give us 1 1 0. So it's not working. So this is not working. If we use or alone, it's not gonna give us this. Maybe we need to combine 2 of them.
For that case, but it worked for the. I think it worked for the case we are given, or it's supposed to work for all the edge cases.
Yeah. So that is like just a test to test the working, but it should work for this. So I can split the problem to 2 cases. So now if we did 1 1, what does, so we only have the problem with 1 1. The XOR here.
Yeah, so we'll change it to 0.
So what's the
XOR will
XOR
change it to 0.
XOR? Let me see. So XOR is 1 when what? When one of the 2 bits are different.
Yes, one of the 2 bits are different. You get you get 1. So 1 0 will be 1. Then when the 2 bits are the same, you get 0.
So if we use XOR here,
XOR won't work with them.
this 1 1 is not different, so it's gonna be 0. 1 0 is different, it's gonna be 1. This is different, it's gonna be 1. This is not different, it's gonna be 0. It also didn't work. What we can do? Okay, someone have a mic open. Any, I will unmute you. I think it. Any, Ibong, your mic is open.
Okay, yeah.
What if? Okay. How we can get this? Think with me. Just by using this right here.
What about starting with OR? Then the result. Yes, then the result can be combined with another operation, which I don't know.
Okay. Okay, we know that OR is working well, right? That can work. We know that OR is working well. It gives us 1 0 1, but when there is 1 1, it's fail.
Because the way it is now, the way the result is, if you invert it, you have it, but it's not consistent. So you can't say all is actually correct. Because if you invert 0 1 1 1, you have 1000.
Okay, let's do a normal operation. Let's see 3 and 2. Let's do like 3 and 2. So 3 plus 2 is 3. It's gonna be 5, right? So now 3 is remind me please, 11? Yeah, 11. 11
yes.
Plus 10?
10, yes.
So 1 0. So this is OR. Or like this is not OR, but like multiplication in binary. How we do like not multiplication, addition. So we do 1 1 1 0 0, and 1 is 1. What is it? It's gonna be 0, and we add 1 here. Then we do like this. Is this 5?
Yes. Yes.
Okay, so this is this is what we're trying to create here. Okay, let me repeat it. So when we do addition in binary, we do 1 plus 0 is 1. But when there is 2 1 1, we do 0, and then we add 1 to the next bit. So 1 1 0. Now because we add 0 here, we're gonna add 1 in next bit, which is this one. With this number have only 2 bits active, so we can just add it here as 1. But if it was for example as 1 here, like it was like this, then again we're gonna do 1 1 1 1 1. Wait, is it we're gonna add it? Actually not sure, but let's see what is this number. 2 3.
If you have 1 0, that gives you 1, then you add to that 1, that gives you 0, carry 1 again to the next. So you're actually correct.
So 1 1, it's gonna become again 0, and then we're gonna add it here, right?
0, then take 1 again.
Let's make sure. What is 1 1 110 with decimal?
That's 6.
6. So 6 3 9 Is this 9?
And it's correct. It's yeah. That's
Okay,
8 and 1,
so
9. Correct.
so wherever there's 1 and 1, we need to add a 1 to the other bit. Okay, now the OR, like we can start with OR and then check when there is 1 1, we somehow set the next bit to 1. No, yeah, just add it. Just add it. So for example, we can do, let's do this, the 3 2 example is more simple. So we have 1 1 0 1. We did like Sheza said, or, right? Or what this gonna give us? It's gonna give us 1 1, right? 1 1 1. Now because we need somehow to detect
What I'm thinking is like we are going to solve it ourselves. All we need to do is just to convert to binary, then we have to solve it ourselves, checking each bit for the next bit, one by one like that. I don't know if there's a special technique for doing that, but the way I see it is if we are going to solve it without using any other special operators or something, that means we have to solve it ourselves. So you have to compare the first bit to the next bit. If it's not the same, like if it's 1 0, that's 1, or 0 1, that's 1. But once it's 1 1, we set it to 0 and keep maybe a remainder somewhere or something, maybe 1, then go to the next bit and continue from there. So that maybe that's how we have to. Just a suggestion, anyway. So
yeah, I get what you're saying.
I think that's the same way we did it in ALX. I think it's similar to the same add function for binary. So yeah, adding like how you add a decimal. So if it gets to the max value for decimal, you move 1 to the next place value. So might end up have to do it like that.
They say we should not use plus operator. That's where I'm looking at.
We can only use this one.
In the question.
So yeah, we can choose plus, we can choose minus. So
can we explore a solution with the shift operators?
Yes.
It looks like we are going to use the left or right.
Yes. So one of the solution is to have a variable of like this that will check if we have what, let's call it addition, what's called this, reminder. So whenever how we can see if we have reminder or not, we can use AND operator, because when we're gonna have reminder, only when there's 1 1, right? So if A is 1 and B is 1, it's gonna if one of them have 1, let me see. Okay, so let's say the bits is 0 1 1 0 and 0 0 0 1. If I did AND here, it's gonna be 0, right? It's gonna always be 0. But it's gonna be different than 0 if at least 2 1. Then I'm gonna have this. So I can, with this AND, detect if I'm gonna have a reminder during this addition. So for example, here we did OR. Now OR give us 1 and then it give us 1, but we still have a reminder here. We need to add it to this here, right? Because these two, Are you with me? Wait. There's a problem here. Because OR it's gonna give us 1. We need to add the reminder to 1 0. So what is the operator that give us 1 0? I think XOR, because XOR give only 1 when it is different. Right? So let's switch this to XOR, and boom, now we have 0. So XOR give us 1 0 1 1 1 0, and because we can detect if this operation gonna have reminder thanks to the AND sign. If AND sign, if we like do A, if we do A and B, it's equal 1, or like a different. If it is different than 0, we know we have a reminder. So we're just gonna add this reminder to this value. Now if we add this reminder to this value, how it's gonna be? So this value is 1 0 plus 1 0 1. No, 1 0. Let me not go fast. Let's. So we said we did XOR. It give us this. Now we did A and B. Now A and B, how much it's equal? 1 and 0 is 0. 1 and 1 is, wait. Is 1, right? 1. And then, okay, we have 1. So the end of this, the result of end, it give us 1, which means we have reminder. There is a 1 here. It's not 0. As long as it's not 0, this means there's a reminder. If it was a reminder, then we're gonna do this value plus this value. Do I do plus or another? Okay, what? We said this is 2. This is 2.
Can I?
Yes. Yes, go ahead, please.
Like, so at that point where you are using the AND one to like find where the remainder is, or the remainder is, okay, let's use remainder. So at that point, we know that this value, we know that at that point we just need to shift the one to the next place value. So
shift here.
So instead we just shift by 1.
So it's gonna be like this and 0.
Yes.
So we're gonna do AND A and B, and then shift it by 1. By 1? This
yes.
By 1. So AND and B. So this gonna give us the reminder. Yeah, by 1, because we're gonna add it. Okay.
So then we can just do AND or think or work better.
Or I think XOR, because we want a 0 when we have 1 and 1.
Yes.
So
no, I mean like to add the AND value that has already been shifted to the value of XOR. That will give us the value of the addition.
Okay, I'm not following.
So you have already done XOR to find the value that needs to be shifted, or that has a remainder that I need to shift. So you want it to be that wherever there's 1 and 1, I want my value at that point to be 0. That's for XOR. Then you now use AND as a mask to get the value that is 1 and 1. So when you do that, you now have the max, you now have the max for, what do you call it? You now have the max for that number at that point.
Yes.
So, and then you know that from your XOR, you know that you are going to take the remainder to the next place value. So you shift left, one step left. So you have the place, you have 1 in the next place value. So what you need to do now is to add this to the XOR and the shifted AND together to get 5.
Okay, let's do it in slow motion. So this is 2. This is 3 is 11. Let's give us 5, right? Is how much? 1001?
No, 101.
101.
Or 101.
101. Okay, so we said we're gonna use XOR, then we use the mask to add the remainder. Let's see if it's gonna work with this formula. So if we did, let's say this is A and this is B. So we're gonna set A XOR B, which means 0, 1, 11. 0, 1 is different, so it's gonna be 1. 1, 1 are not different, it's gonna be 0. Now we have this value, and we know here because this 2 is 1, 1, it's gonna be, we need to add a remainder. Now this gonna be calculated separately with this formula, which is gonna become A, in this case is 10, and B, which is 11, right? And then we're gonna shift it by 1. This gonna give us, so 1 and 0 is gonna be 0, 1, 1 is gonna be 1, and because we shifted by 1, we're gonna add 0 here. So 0, 0, 1. Now this, if we add it, it's gonna be 0. Okay, I see what you said now. So this is OR.
Yes.
Okay, it's gonna be 1, 1. Okay, I can see this will work.
Will it work for something larger? Let's see what happens for something larger. Maybe say 8 and 9.
8, can you repeat?
To check if to work for 8 and 9.
8 and 9. Okay, let's test it. So let's take our magical formula with us. And now 8 and 9. 8 plus 9, let's give us is 17.
17.
Now 8, how much is it in the binary?
That's 1000.
Okay, 1000. And 9 is
1001.
okay. It's about 17. I don't expect you know that. Don't scare me.
Oh, fine. that would be actually 10001. That would be
1001. Yeah.
Okay. Okay. Now this is the result. If we apply this formula we did here and give us this number, that means we're on the right path. So we decide first we're gonna use XOR. XOR on this gonna be 0, 1 is difference, 1. 0, 0 is not difference, 0. 0, 0 is not difference, is 0. 1 is not different, is 0. And this suppose give us one reminder, but this gonna be calculated in another formula, which is this one. And if we apply this formula here, it's gonna be end. So 0 and 1 is 0, 0, 0 and 0, 0, and 1 is 1, and we have shift by 1. So we're gonna select this and get shifted here, and we're gonna add 0 at the end. And now here we're gonna do or and 1
It's working.
0 1 0 0 0 0. Hey, nice work. It's work. Check mark. Now the crazy
Working.
part.
Perfect.
Yeah, it's working perfect. Now the crazy part is how to write this in code. Okay, let's see. Tickets.
We have already written the code.
Can you
I
repeat?
think it's
Code
very
is a
easy though.
one-line
You can
code.
do it. You have the formula. You have the formula already. You have the formula, so you can do
Yeah.
it.
So we have A
It's a one-line code.
and B. Can you repeat, please?
I said the code is like a one-line code.
One
It's like,
line code? How?
Yes. So
Yes,
it's just
now.
A,
Yes. It's one line. You calculate
or
this, then
B,
or
or
A or B.
bracket
Yes. Very
and
simple.
B, shift
Okay,
I and
so
1.
return what?
A, then X or B.
Okay. A XOR
A, X or B, shift, left shift 1.
B, and
A, X or B, then or.
then OR. What about this?
That will be the next. So yeah, adding
Okay,
the
we are
two
just
together. You're doing
this gonna give us this.
Yes.
So let's save it in some variable. Let's say what do we say it? Let's call it
XOR.
number 1, or like or XOR. Yes, that's good. Okay, now we have this value. Now we need to add it to this, but before we do this, we need to calculate it. So it's gonna be reminder is A and B shifted by 1, and then
Then shift 1.
XOR or reminder
Remember.
So or remainder. Yep.
return. Okay, let's run it. Oh, it's work. Good job. Nice work. But
Actually,
sometime-
you don't need the Z or you can even add it there. You can add it there and it will still work.
wait, really?
Like you can put it in one line and it will work.
Yeah, but we can't use plus.
No, like just put the substitute what is in Z or put it for Z or put
No,
what is remainder.
You can use it in one line and it will work. Like you
In
can
one
put
line.
everything in one
Oh,
line.
this
and it
one
will
here. Okay, I see.
Put this one here, then put the other one there.
Yes.
Yeah.
Run. Okay, that's nice.
Okay,
Congratulations. But if we submit, I think there are gonna be errors.
Let's see.
Okay, it's
I don't think so. You have to satisfy
wrong
everything.
answer.
Oh, really?
Yeah.
Wrong answer. Wow.
Now
Wait.
why we have wrong answer?
Can
So
you wrap the
expected is
XOR?
50.
Can you wrap the A and B in brackets?
Yeah.
What do you think?
Wait, can you repeat?
Wrap
Can
A
you-
and B in a bracket. Then
Oh,
wrap A
okay.
and B in a
In
bracket.
brackets,
and
yes, I
wrap
think you're right. Here.
the other one too. Yes, and wrap
This
the other
one.
one as well.
Okay.
Yes, again in the bracket as well.
Okay.
Yeah.
Submit.
Yes.
No. Oh, it's a work. Hey, nice. Wait, is this work? Wait,
No,
let me
no.
see.
The
Wait,
ones that said
Oh, this is the old one. Okay. So submit. Oh, I can.
why 42 all around there.
So
30,
when we give
10.
it 2 and 30, it doesn't work. Okay, I don't think it's that simple. Now, let's see why. Let's apply this number on 2 and 30, and let's see why. What do you think? So a into 30. Let's see why our formula. What does it give us? Our formula? It give output 42. It should give 50.
What's the input? What was the input? Okay.
Yeah.
20 test.
So let's test this manually and see what's going on.
Oh, you know, we're testing with 1 numbers. We didn't test for.
Oh.
Yeah.
Okay. Let's see how we can do this. Let me push this to the side. Now we have 20. How much is 20? Convert 1. Okay. And we have 30. Convert. Now this should give us 15. Let's see what is 15. So it should give this. There. What? Okay, this here and this. Okay. What the heck? Okay, I will just write 0, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, and 1, 1, and 1, 0, 1. Thank you for your service. Now this should give us this. So 0, 0, 1, 1, 1, 1, and 1, 1, 0. Notice here 1, 1 gives 0, but they add 1 here, and because 1, 1, 0, they add another 1 here, so it gives 0, and 1, 1, 0, but because the addition is 1, 1 is 0 is 1. Is it? 1, and because the first addition was 1, 1, 1, it's become 1. So you do 1, 1. What is it? It is 0. So they add 1 here, and because 0, you add it with this reminder, so it become 1. And now we need to go to other side. 1, 1, 0, 1. Is this clear? I can repeat it. I maybe did go fast.
Got it.
Can you repeat?
I said got that.
Okay. Now, in our case, it's given 42. How is that even possible?
Maybe because of that.
We're missing something. Now, in our case, it's given 0, 1, 0, 1, 0, 1. So this one is correct. Oops. Okay. What happened here? Okay, let's see if we put this and B in our beautiful formula. What's gonna happen? Okay.
I think you might be getting it from where you have to do where 1 is 1 and 1 are the same. Then you now have to add another 1 to it.
Maybe it's the nah. Can you repeat, please?
Oh, it's not that. Oh, okay. It's for moving the remainder. That's where we're getting the issue.
Okay.
Maybe the shift this thing.
Yeah, the shift.
Let's take it and see how we can get this result. So
Let's
what? So we have this.
We can see.
It's better to what?
Like we go through it so that we can see what's going on exactly.
Oh, wait, I'm confused. What you said?
Like it's better we.
No, you think you should run
Yeah,
through
yeah.
it. Just run through it the way. So
Yeah,
we
yeah.
can
Let's
know
do it one by one
lines
and
like
see what happens.
Yes.
So A and A XOR B. So 0 XOR 0. It's gonna be difference. So it's gonna be 1, right? Is it true? Let me check. XOR 1 if 2 bits are different. Okay, so it's gonna be 0. This is not different. 0 0. 0 1 is different, so it's gonna be 1. 1 1 not different, it's gonna be 0. 0 1 is different, it's gonna be 1. 1 1 is not different, it's gonna be 0. Okay, so far it's good. It's working fine. Now the other part is gonna calculate the remainder, which A and B, and then we're gonna shift. Let's calculate A and B. 0 and 0 is gonna give 0. 0 and 1 is gonna give 0. 1 1 it's gonna give 1. 0 1 it's gonna give 0. 1 1 it's gonna give 1. Now this is the remainder. Because we have shift 1, we're gonna shift it to the left by 1. So then now because we shifted, it's gonna be at 0 here, and this we're gonna do OR here. OR. Now let's see what's happening when we're gonna do OR. 0 or 0. 0 1 1 0 1. Oh, we need to do reminder again here. You see? Because 1 and 1, it should give reminder to this. So OR is the problem. OR is not working. Because if we did OR, what's gonna happen is 1 and 1, it's gonna give us 1. And we don't want that. We wanna do 0. And then give reminder to this. Okay, so maybe we use XOR again.
Shifting again. Okay, go ahead.
We can do XOR again because we know that XOR gonna fix this. So let's see. I hope everyone know what was the problem. That's why it didn't work. Now, if we did XOR, what's gonna happen is this. But if we did XOR, we need again to do the same. Okay, so maybe we should do. Okay, let's do XOR on this again. So let's start again with XOR. XOR 0 and 0. It gives us. Let me read it again. XOR 1 if 2 bits are different. So this is not different. It's gonna be 0 1 0 difference, 1 not different, 1 1 not difference, 0 0 not different. I don't know why it took me so long to catch that. And 0 and 1 are different, so it's gonna be 1. So this is our XOR. Again, what we're gonna do is we're gonna apply our secret formula, this one, on this bot, and then we're gonna do XOR on them if this formula is not equal to 0, because as long as this not equal 0, this means there is a reminder. So as long as there is a reminder, we should keep going XOR, 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 like a loop. So this is a very long number, probably not gonna finish until tomorrow, but maybe it's just need one loop or two. So my idea, we'll try to say it again slow. So notice here that we always gonna need XOR, and then we're gonna need to how to say, do this formula, no, how to say, it's a reminder to check if it have one complement. So this one is gonna say yes, I have one complement. Thinking. So we can do like or. It's really hard. Any idea?
Have you tried doing a double left shift to see if that will work? I just a guess. I'm guessing of this.
So
Like
we're
a
gonna
double left
shift
shift.
by 2 zeros. Here. So this gonna be
Just testing. I don't know. You can try that. It works.
okay.
I don't know.
Okay, so where we did shifts? I think we shift here. Where did we shift? Yeah, we shift here. So we did A and B 0. Wait, which one we did shift? We can repeat it. Wait. So this is, we said, the real value. This is the wrong value, and we saw how to how we get it. So we did A and B. A XOR B, so 0 different 0 0 different 1 1. Wait, is that correct? Oh no, I'm processing the wrong one. This one. So 0 0 0 or different 1 1 1 0 different 1 and 1 1 0. Now the parts where we're gonna shift, let's do the end first. So the end gonna be in the 0 0 0 1 and 0 1 0 1 0 1 is 0 and 1 1 is 1. Now we're gonna shift it by 2 right here, right? It's gonna be 0 0 and then we're gonna do OR, which 0 1 0 1 1 0 1. No, it's not the same.
I don't think it didn't work. It didn't work. Yeah.
Okay.
If I were to expand on the loop method, we can go through a loop, replace A with A XOR B, and replace B with the reminder, and then you keep looping until, as you said, until it's 0, and then you return A, maybe?
Okay, so that's something I was thinking about. I think we did this in Alex in some task. So like this loop right here is gonna be looping on each number. So we have A and B. How I can explain this? Let me think. So we have A and B, right? We first okay, I lost it.
So while B doesn't equal 0, you have A equals A XOR B, and B equals A plus B? I'm not sure.
Okay, while B equals 0, but B gonna be changing, because if you notice here, every time we find a new variable, that so B is gonna be this.
Exactly, that's the point. You keep looping through it until it becomes 0. That means there's no remainder.
Okay, so b equal a and b 1 probably shouldn't set it here, because what if it was 0 from the start? Maybe it's not gonna enter.
I mean, isn't that the point? If it's 0 from the start, then it's just a. A plus 0 is a.
Okay, so okay, so we have b. Then we said we're gonna do this part. So let's say a is a XOR b. Now our b, it should be a and b.
Maybe we set a to something because we're still gonna use it.
Set a to something?
Yes, we're gonna use it for b.
I don't follow.
So we're changing the value of a, but we're still need to use the original.
Okay. So we need to do it before. Yeah. So reminder maybe equal here. So the value don't change. Why is this guy? So while, so this is inside the loop. Reminder is this, and then the reminder is b. So this way we didn't change. Okay. And let's see if this gonna work. Let's choose some small number. Because I don't know how much this gonna take to loop. Okay. Let's say we have. Okay, what if we did here? Let me see. Test case, and we add a new test case. Test case 2, 3. What about 2, 5? Is this gonna work? We need to test the where it doesn't work. It work. What could be the simple number? So maybe some number that's have 2 complements.
Let's try numbers that you have to carry a lot. So let's say 2-digit numbers. Maybe
we found.
10, 11.
Okay, we found one.
Or
3 and 5. So 3 and 5 didn't work. Let's go 8 because this probably have 2 complements. Because our case here, it's only check one. It's only check for 1 complement. Maybe with the recursion it's gonna work. Yeah, what if we did? I think we can do recursion.
I mean, it's the same condition that you're gonna use for the loop, you're gonna use for the recursion. So they're basically the same.
Yeah. Do you see a recursion here?
You're gonna use the same condition, so you're gonna check again if b.
Okay, let's continue with this. Let's see if this is working for 3 and 5. So we have a 3 and we have a 3 and b is 5. Now 3 is how much in decimal is 11. and 101, I think. Somehow I remember.
Yes. Yes.
Okay. Now we're gonna do, let's follow this program and see if it's gonna work. Now let's apply maybe our formula to see where is the problem, why it didn't work, then we apply this program. So if I apply this, we have A and B. So first of all, let's see how much this should give us 8, right? 8 is what? 1000?
1,000.
1000. This is the correct answer. What it give us, for us, it give us 6. Okay.
Wait, can you just replay the screen again? So
Okay.
you are trying.
This one?
Yeah.
This screen?
So yes, this one. So the operation that is being done now is XOR, right? XOR between three
yes,
3 and 5.
XOR. Yes, XOR.
XOR.
So now in
So how did you reach to the number 1000? It should be
this is the correct answer.
It should be 100 because XOR the value will be set. In other words, it will be 1 if the two bits are different. So the first, so if we take them from the least significant bit, so we take 1 and 1, they are the same, so it is 0. 1 and 0, they are different. It should be 1, not 0.
Yes. So this is not the result of this. So this is the correct answer as like what is 3 plus 5? It should be 8. So, which is this one, right?
Sorry, your voice was breaking. Can you repeat?
Oh, so what is 3 plus 5 is 8, right?
Yes.
So 8 is 1000. Okay, now in the second line, we're gonna do this formula. This formula is give us 6. Right? Now, how much 6 with the binary?
6 in binary, it is 1, 2, 3. So it is
100?
2. No, it is 0, 1, 1. 0, 1, 1. 1,
1. So for us, it gives us 6. If we say here, the output is 6. Now the output is 6 is wrong. Now we wanna split this formula, see how this 6 where it come from and where is the error. Now then we're gonna apply this loop and see if it's gonna fix the error. Okay. Now how we gonna start it? We're gonna first do A and XOR B. So A XOR B is gonna be 1 XOR 1. They are not different.
Yeah, 0.
So it's gonna be 0. 1 is 1. 1. This one is
0. 1. Yes.
Now, okay, so this is 6. Then we go to pipeline.
Or yeah.
A and B.
The pipeline A and B left shifted by 1.
So we're gonna do 1.
Let's apply A and B first. So 1 and 1 is 1. 1 and 0 is 0. 0.
Then shifted.
And then shifted by 1 bit to the left, it is going to be 2. We'll have
or
wait, why you put 0 on the least significant?
We shifted by 1 to the left. So this is
because
the end. This is the end, right?
Yeah, this is the result of the AND, and we need to left shift it by 1 bit. We need to left, so it should be 2.
So basically, what one shift to the left is you move this one time to the left.
Yes.
And you add 0 here.
Okay. Sorry. So it will be 2. It will be 2.
Yes,
yeah. 10. Yeah. Okay.
And then we do OR. So OR 0, 1, 1, 0.
0.
So it didn't change. So that's why it gives 6. That's why this formula is not working. Or it's working, just need this loop Because again, we found out another problem is this. Notice 1 and 1, it gives us 1.
Yes.
So when we're gonna use this loop, what's gonna happen if there is this 1 and 1? Because while b is not equal 0, which is
so what
common.
What is the expected result? Actually, like I just barge in without even knowing what is.
So
the
it
outcome
should give this.
look like.
It should give this.
So the
8.
end result should be 8.
8. Yeah. Now we're gonna test this 11 and 101 on this while loop and see if it's gonna work. Let's see. So we have the value b. Let me clean a bit this stuff. Now we have the value b is this, and b and so 1 1. So
Okay,
b
on
is gonna
another
be.
thought, maybe B shouldn't be changed before the loop. That's kind of.
Because I think if somehow becomes 0, we're not gonna enter. Yeah, because while b is not 0. Yeah, so we're not. Wait,
I think we should enter without changing the values of an A and B.
Okay, yes. So while b is not 0, because if we add a to 0, we just return a, right? So as long as b, for example, in this case is not 0, we need to calculate this. And then we're gonna change b. So let's see.
Sorry, I want to say something.
Yes. Yes.
Okay, so what I think we should do is this. Like when we are solving a normal mathematics question, you know, we do have like reminders, like carryovers, when we have carryovers. So now, I think that is in place in where we have a reminder. So I think what we can do is, since A and B is the carryover that we get when we XOR A and B. So I think the reminder should just be A and B without the left shift. Then why the second line, which is A equals to A XOR B, I think is correct. Then the last one is where the issue is. Now, since we have our reminder, you know, the reminder is what is going to be carried over to the next side. Then I think that is when we need to left shift it. So whichever one that is remaining will be reused in the second loop. I don't know if you get what I'm trying to say.
Yeah. But this one gonna use in a second. So this is our carry actually.
Yes. But the problem is, like, you have already left shifted it here in that place, which is not supposed to be so. We should just get the carryover, and then all I say it's the next time that B will be XOR with it, then that's when it should actually be used with A.
But we don't use it here. We already shifted, but I'm not gonna use it until the next time when I'm gonna do this.
Okay. Let's just give it a try.
Okay. So we do reminder. The reminder value, let's call it R, is A and B shifted by 1. So 1 and 1 is 1. Sorry. Yeah, 1 and this 0 and this 0. We shift it by 1, so we add 0 to the left. Right, this is our reminder. Then A is gonna be A XOR B. So A XOR B, 1 is not different. So 0, 1 and 0 is different. So 1 and 0 is different. So 1. So this is the value of A, right? Now, this program return this. But when we're gonna do while loop, we're gonna see that the remainder is 1, is not 0. So we still need to process this. So what we're gonna happen is our b this time. So we're gonna process this number with this number, right? Because we have 1 and 1, so we need to add 1 here to this side. So in this case, okay, 0. Wait, did they shift this? I think I shifted 1 1. Yeah, I did shift. Okay, so b is gonna be equal to reminder, so this gonna be again just 0 0 1 0, the same. Now we're gonna loop new line, right? Okay, now when we're gonna loop, a reminder is what here? A and b is this, and the loop did enter. Why did the loop enter? Because b is different than 0. If we see, yes, b is different than 0, so the loops continue. So this loop is gonna keep going until this equals 0. And when this gonna equal 0? When we don't have any reminder. Okay, so the next loop r gonna be and be shifted by 1, a 0 0 0 1 1 1 0 0. We're gonna shift it by 1. You basically just select it and move it to the left and add 0 to the left side. Now we have a XOR b, so a is gonna be equal to a XOR b, so 0 XOR 0, they are not different, so it's gonna be 0. 1 1, they're not different, 0. 1 and 0 are different, so it's gonna become 1. 0 and 0 are not different, so 0. Now b gonna be equal to reminder, which is 0 0 1. Now we're gonna go to the next round. Next round, new loop is the loop gonna enter? Yes, because b is not 0. Now we have r again. R is and b, okay, and a 0 and 0 0 0 0 0 1 1. This is our a, and a this is our r and 0, and a is gonna be a XOR b, so
don't forget to shift it.
Oh yes, correct. So that and that. Okay, so a is a XOR b. This is a, this is b. 0 and 0 not different, 0. 0 and 0 not different, 0. 1 and 1 are not different, 0. 0 and 0 are not different, 0. Oh, okay. I am correct here, or yes, it's good. Okay, so a is 0. That's good. Now b is gonna be equal to what? To a reminder. Now the reminder is 1000. Now we're gonna loop again. Is the loop gonna enter? Yes, because b is not 0. Now again, another round. Hope this program gonna finish at some point. Okay, so reminder is a and b, so this is our a, this is our b. 0 0 0 0. Oh, no way. So our reminder actually finished. So we're gonna shift this again and we add 0, so reminder is 0. Now a is gonna be a XOR b. A XOR b is 0 because they're not different. um 0 and 0. Wait, they're different. They're not different. Yeah, they are not different. Yeah, okay. So 0 0 0. So basically XOR is like it's gonna give 1 if two value are different. So 0 0, it's gonna give 0 0 1 are different, so it's gonna give 1. Now A, it's gonna be this value 1000, and B, it's gonna be equal reminder, right, which is 0. Now are we gonna go to second loop or other loop? No, the loop gonna stop here. Why did it stop here? Because B is equal 0. Okay, so where is the result? Where is it? Is it the correct result? Yes, this is 8. So basically we return after the loop stop, we return A. Right, we return A. Or we return B. Yeah, we return A. It's gonna work?
We return A, I think. I think we return A.
Yes. So I think it's gonna work. Do we test it? Is anyone have question? Like is the idea or the loop understand it well? Let me read question. Anyone have question? So everyone understand how this loop work.
Yes.
Okay. So now there is one small problem. Is this probably not gonna work because this while loop in Python there is a lack of fixed bit integer or something like this. We're gonna see it. Return A. Return A. Yes. Let's see. So I think it's gonna work here fine. It fixed our problem. So yeah, good job. Let's clap. Let's clap. Let's clap. Nice work. Nice work. Nice work.
Congratulations.
Thank you, Sabah. Thank you, Sabah.
Thank you, Sabah.
Thank you, everyone. So it fixed our problem. But when I'm gonna submit, there's gonna be a problem. So
let's just add test case for that 20 and 30 again. Oh, okay, I already submitted.
Yeah, I'm submitting. So one of the problem gonna work is not because of the logic, but because of how Python work. So this is in Java or something gonna work. I think. Let's do it in Java. Let me how we convert this code to Java. Convert this Python code to Java. Okay, wait, bro. Just this. Thank you. Okay, submit. Okay, accepted. And 100 bits in Java is working. Someone may ask, like, wait, why it didn't work in Python? What the problem? So the problem is gonna find it here. Let me post this document. You can read about it in details. Overflow Python problem, and it's you can actually solve it. So we can solve it by doing something like this. Mask. And we can do B and mask. then this is gonna be like less then here we should return. We should check here, I think. I forgot. I saw it somewhere, but I forgot how they did it. Return F, I think. Does someone know this part?
Can you at least explain the issue first?
Okay, so the issue. Okay, I didn't explain the issue. I'm sorry. So the issue is like in Python, there is no fixed numbers or like integer. So for example, in Java, if we can work with 32 bits, but in Python there's no limit. It will take as much as the memory it's allow. Let's read it here. Python handle integer differently than some other languages. In many language, integer are fixed size. They can be 32, 40, 64, etc. And they overflow when the result of an operation is outside the range. This can be represented with that number of bits. For example, in a 32-bit signed integer, the range is -2 power of 31 to 2 power of 31 minus 1. If you add 1 to 31 minus 1, you get -2 power 31 because of overflow. Let's jump to an example because it's hard to understand that. So normal, like let's see, for example, C++. If we did if like we add, so this is the max int, like max 32 is this, yes. So max, if like all 32 bits are full, this is the decimal number, right? If I add 1 to it, it's gonna flip it to minus and that number, so the int mean. But in Python it doesn't do that. In Python, if you have the max number, when you add 1, it stay positive and it become like 80. If you say it here, like it's added. So like it doesn't how to say, it doesn't overflow it or like convert it to int mean. So that is the problem. You can read about it more, because for me it's also new, so I don't understand it really well. But how you can fix it, for example, for Python, you can use the mask. So the mask gonna like eliminate or like remove any other bits. Okay, I know this is not clear, but just do some research, it's gonna become more clear. I'm also still searching about it, so I am not able to like explain it really well. But as a fix for this, we can do like return a mask if b. I will explain this part. Else a. So I'm gonna return this, or I'm gonna return a. So why I'm gonna return a? Because the number didn't overflow. But if it did overflow, that means b is greater than 0. Right, let me see. Okay, I forgot it. Is it okay? Return and mask a. So what this gonna do is gonna yes, it is. So let's say b, let's say this is 1 2. Let's do it in Excalibur, but you need to write like 32 bit. let's do just 8. Okay, let's just say we have 8. 1 1 1 1 1 1 1. Innocent, your mic is open. There's some background. So because this is sign, right, this integer here represents the sign. Now when we are looping through this loop, our number may get like bigger, like this, like this. This is it's what's the problem. In other language, when it gets more than 32, let's say this is 32, what's happened is it's become minus, right? Because the last bit is for sign. In Python there's a problem. So what we can do is just use the mask. So for example, this is ff. So I'm gonna do end 0xff. What is 0xff? This is hexadecimal for 0 0. So like it's gonna be 1 1 1 1. If this first f 1 1 1 1, and everything 0. From the left side, everything 0. So when we're gonna do end this value with this, what's gonna happen? It's gonna filter all the others. So this one gonna become 0 0 0, and this gonna stay the same value. So if it was 1 1 and 1, it's gonna be 1. Let's say this is 0 1 and 0, it's gonna become 0 because end, right? So the value of the a is what's gonna reflect here, and at the end we're gonna eliminate all this which was causing the, so we're like doing like simulation of overflow.
Okay, sorry. So
yes.
It's like truncating all the leading zeros.
Yes, but I don't like understand it well to like explain it to you guys, so maybe in next PLD or something. But now we know that our logic is working fine, so maybe in interview use Java instead of Python, or if you understand this well, we can do something like this. We can, if no one have question, we can end PLD here. Also in this document is explaining well, I just didn't have time to go all of it.
Did you submit with the changes?
Okay, let me submit this new one. Submit.
You did remove those ones.
Yes, it worked.
Those ones.
Yes, it worked.
No, it still worked, sure.
Yes. But you can see the performance is very low. Okay guys, any question? If not, see you tomorrow. Tomorrow we're gonna have I think maths and geometry. Okay, see you tomorrow at the same time. Have a good night. I love you all.
Thanks. Next. Bye.
Bye. Have a good night.
Good night. Thank you.